Okay, now we're going to have a look at a quite useful application to do with work. So we're trying to find, we've got a particle acted upon by a constant force F, moving from point A with position vector RA to point B with position vector RB. So what that means is that we've got a couple of points. So let's just start with an origin. We've got our point A and our point B. So we're going to move our point from A to B. So it's going to move like that, where A has got a position vector RA and B has got a position vector RB. And from what we did previously, we know that this vector in here is RB minus RA. So that's RB minus RA. So that's the vector of the movement. And we're trying to find the work done when a particle moves like that due to a force F. Now the key thing here is that the force F doesn't have to be in the same direction. So we could have a force F going up here. It's a force, it's a vector. A force is a size and a direction. And we'll have it at some funny angle to the direction of motion. Okay, and the key thing is that work is equal to force times distance, but it's only distance in the direction of the force. So the only bit of the distance that we're interested in is this piece here, the distance in the direction of the force. So we'll call that D. And then work is equal to the force times that D. Okay, that's the definition of force. Work is force times distance, but it's only the distance moved in the direction of the force. And it turns out that work is actually equal to RB minus RA dot with the force F. So you just do a dot product between the vector of motion and the vector of force. And if you want to be convinced of that, then by the definition of the dot product, that's equal to the mod of RB minus the mod of RA times the mod of F times the cosine of the theta in between them, and the RB minus RA, this length here, times the cosine of the angle is going to give you length D. So that's just equal to length of D times the length of F, which is exactly what we said was equal to the work. So if you're trying to find out work with a force and a distance, all you need to do is do the dot product of the two vectors, the vector of the motion and the vector of the force. If you take the dot product of those two things, you'll get the work done by that motion, or by that force during that motion.